The study of genetics has both confirmed and informed much of what we know about our evolution, like if you trace your genetic ancestry or take a paternity test, except, of course, that it reaches much further back. Now, biologists have sequenced complete genomes for thousands of different species already, and so far, every genome ever retrieved from any animal always confirms an evolutionary phylogeny, a biological relationship with every other animal and a growing network of them. And more than that, when you feed all these data into a computer, it resolves a taxonomic hierarchy or a family tree showing which ones are more closely related and how. Here's an example of that with just 100 or so species included. Here's another example, but this one has the DNA of a few thousand species included. And that's important, but it goes deeper even than that. There are several studies like this one that calculate not only the phylogenetic relationships, that taxonomic tree, but it can also date the nodes, the points of divergence in that tree, by matching radiometric dates of associated fossils when evaluated against the molecular clock of averaged mutation rates. Those results have been consistent, effectively confirming paleontology as well. For example, you see this red vertical line? This represents the Cretaceous Tertiary boundary between the Mesozoic and Cenozoic eras. It's called the Cretaceous Paleogene now, but either way, it's a real boundary in the form of a thin layer of iridium that rained down all over the globe as a result of the asteroid that killed the dinosaurs roughly 66 million years ago, give or take 30,000 years. This thin layer of iridium lies on top of Cretaceous strata, effectively separating the age of the dinosaurs from the age of the mammals that followed. Other than birds, there are no dinosaur fossils found above this layer, but there are a few fossils of early birds and mammals found below it. Phylogenetic studies of the molecular clock show that several of our modern mammal groups had already diverged on that side of the line in the Mesozoic when they were still dinosaurs. Actually, there were lots of mammals before that, but those were mostly fossil forms of different types of egg-laying mammals that you wouldn't recognize or understand if you saw them alive today. And we don't have their DNA because they're extinct. Sometimes we can get DNA from fossils from relatively recent extinctions, but this far back, no, there's not a chance. Now, this chart is only for eutherians, taking and comparing the DNA of placental species only. If this study had included DNA from kangaroos, wombats, possums, and koalas, then there would be another branch at the base here, because the lineage of eutherian placentals began after their divergence from metatherians like marsupials. And if it included DNA from the platypus and echidna, then there would be another branch even lower than that, because monotremes are the oldest living mammals. I've already done videos on some of these eutherian groups like Setiartiodactyla and some of the carnivora, and of course primates, but I haven't yet covered either of the first two branches on this chart, which I think would be better understood if we looked at them on this chart. Now, all the phylogeny videos that I've done on mammals so far were on Boreoeutherians, or the mammals from the north. Euarchontoglires is where we are, and Laurasiatheria is where every other mammal is that I've made a video about. This time, however, we're going to look back at that other branch, the southern mammals, Atlantogenata. It's divided very simply on either side of the Atlantic. I'll make a video on Xenarthra later this year. That's a mammal group that arose in South America. But today we're talking about Afrotheria, a distinct group of placentals that emerged where? Well, obviously, Afrotherians are from Africa. I'm still going to do some more videos on Boreoeutherians because that is a really huge group with lots of stuff that deserve their own show. It's not like I'm moving on to this because I'm done with that. No, there's a lot more there. Look at it like this. If you took the road to Boreoeutheria, then you can turn off to either Metropolis or Gotham City and all that in them is. But if you take the road to Atlantogenata, then the next fork is a choice between either Mapleville or Smallville. In other words, there's not that much in Atlantogenata. Let's look at the two main divisions of this group, starting with Afro-insectivora, which sounds like either a disease or a perversion, or a diseased perversion. But it refers to Afrotherians who love insects.
And all that implies.
You might remember when I said in another video that the basic template of all placental mammals is something that looks like a shrew. Likewise, the basic template of metatherians looks like an American opossum, which is the marsupial version of a shrew. So that's how these two groups started out. And then we talked about how we start with that ball plan and make minor adjustments here or there to get to the base template of all these later groups. The same applies here. Look at Afro-insectivora. This means the Afrotherians who not only love insects, but love to eat insects. Actually, that's the same as Afro-insectivora too. It just doesn't sound as creepy because all of these eat insects. They don't love them otherwise. Afrotheria doesn't include elephant birds or elephant seals or Ella Fitzgerald, but it does include elephant shrews, here in the order Macroscelidia. They're not really shrews. They're closer to elephants than shrews, and they're often used as an example of how Afrotheria started out. On one side, we have a larger version of that, but that lost its teeth the same way that pangolins and anteaters did, so that they can only eat ants like those others do too. And this is an example of convergent evolution. That's when different lineages adapt similar attributes to do the same job. That's why anteaters and aardvarks look so much alike. But we have more examples of that on the side that kept their teeth too. All of these, everything in this clade, represents another form of convergence. Look at Afrosoricida, a name that means that it looks like an African shrew. Well, of course it does, because that's what they are, or modifications thereof. They're not true shrews, but they are the African version of that. I've also seen this categorized as Tenricoidea, which I think is more appropriate, especially if we're going to look at it in detail. First, we have Chrysochloroidea, or Chrysochloridae. Just as true shrews led to a lineage of moles, so the Afrotheres have their own take on that theme too. The golden moles are similar to true moles, just the African version. That's not surprising because there's a marsupial version of these too. And there were other versions of that in the fossil record. Moles of one type or another have been in the ground since before mammals were completely mammal yet. Tenricoidea has two more lines of convergence to show. Potamogallinae are a lineage of otter shrews, things that look like shrews but that have adapted webbed feet and live like otters. Then we have actual tenrecs, which diverged from these faux otters sometime between 47 million and 53 million years ago. Then they somehow floated over to Madagascar, which was never a part of Africa. It's a piece that broke off of the Indian subcontinent and just never got any closer than that. But tenrecs made it over there, probably floating on debris, and then they evolved into 30 different species on different parts of the island. Some tenrecs look like shrews, just like you'd expect, but some of them look like moles too, and others look a lot like an Afrotherian adaptation of hedgehogs, which are themselves another version of the echidna. You know, the echidna is a monotreme, meaning that it has a cloaca like reptiles have, like birds have. What would be a vagina and colon that are separate channels on all other living mammals are just one hole in monotremes like the echidna. And strangely, that's true of some tenrecs too, specifically female lesser hedgehog tenrecs. It's obviously like an atavism, like when an evolved trait is secondarily undone or reverted. And that's not their only primitive trait. They also have an unusually low body temperature for a mammal, which again is just like monotremes. A couple other interesting facts about tenrecs is that the lowland streaked tenrecs can also communicate by rubbing specialized quills together to make a squeaking sound that is so high-pitched that it's beyond the range of human hearing, an absolutely unique means of communication. It's also possible, though not yet confirmed, that they might use echolocation. There's a strange collection of traits from other mammals that are copied in the tenrec. Now let's get out of Mapleville because, as you know, there's bigger things happening in Smallville. The sister set to Afro-insectivora is Paeongulata, and the basalmost set in that group is Hyracoidea, known today for the hyrax. What may look at first glance like a short-eared rabbit or an evil guinea pig or an ambitious hamster is not a rodent, nor is it convergently like a rodent. Rodents are known for their oversized incisors, what we call buck teeth. But if you notice, the hyrax doesn't have that. Instead, it's got these little vampire teeth. However, those are not fangs. Fangs are made of canine teeth, but those are actually incisors, just like the rodents have, except that these are separated and pointed, modified into points instead of shearing blades like most incisors usually are. The hyrax doesn't use these pointy teeth as fangs either, no. They don't use them for eating at all. They eat with their cheek teeth, and the teeth in the front, these little pointy bits, would be tiny tusks. The hyrax is an interesting animal also in that it has 4 toes on the front feet, but only 3 toes on the back. That's weird. And the only other time anyone has ever seen that was on an early fossil horse that used to be called Eohippus before someone changed the name to Hyracotherium, naming it after the hyrax, even though there's no relation to it. Another similarity is that while the hyrax has claws, they're barely claws. They're not long and thin and sharp. They're short, stubby, and blunt, and almost like hooves. These are a transitional species, not a fossil, but a living animal that's still showing traits that are intermediate between the combination of claws and fangs as compared to hooves and tusks. Yeah, back in 2020, I was on a paleontological expedition in the South African Karoo, and the team dropped me off alone to wander around for 8 hours or so because everyone had to survey their own area to cover the most ground. At some point, as I'm plodding along, kicking rocks and looking for fossils, I accidentally spooked a hyrax that was hiding in some thorny scrub. You know, if you're wandering alone in the African wilderness and you get to choose which of the local wildlife might come charging out of the bushes, a hyrax is one of the safest choices. The one I saw was a rock hyrax, one of 7 surviving species in 3 genera out of only 1 surviving family. But there used to be a lot more. Sigeurus is the oldest and most primitive hyracoid known to date, and one of the earliest known fossil Afrotherians. And microhyrax, not surprisingly, is one of the smallest. Because remember, these all started from a form that looks like a shrew and was about the size of a shrew. But this lineage went from hunting insects to eating plants. And one trend you may have noticed in a lot of the animals that eat plants is that they very often get big. For example, look at megalohyrax from the Eocene, 55 million years ago. Well, I guess it's relatively big, bigger than the modern hyrax anyway. But what about titanohyrax from the Oligocene, around 30 million years ago? Well, that's about as big as they got, I guess. But it's from something like this, a panungulate of about this size and shape, that is the beginning of each of the remaining branches of the Afrotherian family tree, all of which branch off of Tethetheria, meaning mammals of the Tethys Sea, which was an ancient ocean connecting the Atlantic to the Mediterranean to the Pacific until about 34 million years ago when the Indian subcontinent crashed into Eurasia, closing all that off. We're talking about developments that occurred before then, when the northern and eastern shores of Africa and the southern shores of Eurasia would have been the Tethys Sea. And Tethitherians were apparently initially all semi-aquatic. Toward the base of Tethetheria, we have generalized, vaguely hippo-looking things like Stylophus. The claws aren't really claws anymore, they're hooves now. And this represents the basic shape from which we derive all the remaining groups. This one is at the base of Embrythopoda, which includes more of the same, like Crevadiatherium. There are no good illustrations for most of these, except for the one famous exception, Arsinoitherium. Now, there are plenty of good illustrations and even some CGI animations of that one, like this scene where one is chasing a time-traveling nature show host. These doubled horns make it look like a rhino, like if you tried to make a rhino out of a hippo. But a rhino's horn is made of keratin, so it's like a fingernail growing out of their face. Arsinoitherium's horns are made of bone, and they're hollow, so they're not as heavy as they appear to be, and the empty cavity of the horns are also connected to the nasal cavity. So they might have had a fantastic sense of smell, or they might have been useful for resonating unique trumpeting sounds. The next clade of Afrotheres, of panungulates, and of Tethetheres are sirenians, named for the sirens of Greek mythology, typically synonymous with women who are not only beautiful and inviting, but also cunning and dangerous. I've known a few like that in my youth. The sirens are often depicted as mermaids because medieval sailors, lonely young men too long at sea, would come to places like Florida and see in the water what they thought were mermaids. They obviously had a different standard of beauty back then. I wonder how much rum you'd have to drink before you think of that as a mermaid. Now, why are these in our study of Afrotheres if manatees are found in the Americas? Well, they swam there, didn't they? And the condition of the Tethys Sea at that time meant that they didn't have that far to go. And back then, they could follow warm coastlines the whole way. The Sirenia is not just manatees. There are also dugongs, which are arguably more derived, because while manatees have a rounded paddle for a tail, dugongs have a double-fluked crescent like a whale's tail, which is much more efficient. The same is true of Steller's sea cow. At 9 meters or 30 feet long, this dugongid was by far the largest of all Sirenians. It was named for George Wilhelm Steller, a German naturalist, or what we would call a scientist today. He documented the first written description of the animal in 1741. It was buoyant, always floating at the surface, and it was reputed to be easy to kill and good to eat. The word of that spread quickly, so that it was hunted to extinction by passing sailors over a span of just 27 years. So why don't manatees have the same type of tail as the dugong? You might think that the rounded tail is a primitive trait and that the tail of the dugong is more derived, but the fossil record shows that dugongs came first. They developed the more performance-oriented style of flukes that whales have also. A number of other vertebrate lineages have returned to the sea, and that environment imposes strong demands on the one shape that these animals must eventually adopt in order to live that way. But the manatee paddle is a permissible secondary adaptation to a lackadaisical lifestyle and the mindset of, this is good enough. It's kind of like when some vehicles started out as versatile, sporty performers where you can take the top off and go off-road, but then later models can't do any of that.
Chevy Blazer. It never forgets it's a tough truck.
50 years later, yeah, it finally forgot. Blazer isn't tough anymore. It's not even a truck anymore. You can't even take the roof off. Sirenians are not as derived as whales are, so they still have a number of transitional features that whales lost long ago and that can now only be seen in their fossil ancestors. For example, manatees started out with hooves, just like the first whales did, but manatees still have the remnants of those hooves visible in their flippers. There is no possible use for these fingernails in their flippers. Of course, the skeletons reveal five-fingered hands inside those flippers, just like you'd expect of evolution. And their forelimbs still have elbows, which don't serve any purpose in swimming. That's why whales lost those traits so long ago. And looking at the skeletons of both manatees and dugongs, one of the more obvious features we see is that both have vestigial hind limbs. Now, why would they have hidden hind legs unless their ancestors used to have legs? And when we look into the fossil record, that's what we see. We can start with Eosiren from roughly 33 million years ago, and we see a basic dugongid, not that different from what we have now. But if we jump back to, say, 40 million years ago, we have Eotheroides, which is, again, an obvious dugongid. But at the same time, we also have Proboiscidea, which had back legs. Although it's obviously semi-aquatic, we would have said that it was primarily terrestrial, a side branch that never moved back into the water completely, except that its fossils were found in Jamaica. Now, to be fair, Jamaica was a lot closer to Africa back then, and genetic studies imply that Sirenians diverged from other living Afrotherians 64 million years ago. Africa and South America were a lot closer together then, but it's still surprising. If we go back another 6 or 7 million years, now we have fossils of Proboiscidea in Spain and Proto-siren, which was found in the southern U.S. and in Europe, as well as northern Africa and the Indian subcontinent, which was still an island at that time. And both of these sirens had externally visible back legs, but they weren't really useful as legs. These were heavy-bodied animals with little spindly legs that couldn't hold up that huge manatee. They had legs that they couldn't really use and didn't need. So, of course, it's no surprise that if you look back to 50 million years ago, we find Pesosiren portelli, which, like Proboiscidea, had fully functional hind legs and could amble about on land well enough if it wanted to. Pesosiren was in every other respect a modern manatee, except that it still had a definite, albeit reduced, pelvis and 4 still fully functional legs. The tail was missing from the fossil, and so it might have been heavier than is indicated here, as they evidently used them early on. Otherwise, Pesosiren must have occupied a similar niche to what hippos do now, spending almost all of its time walking in the bottom of shallow waterways, which manatees today still do. Paleontologist Daryl Domning said we have essentially every stage now, from a terrestrial animal to one that is fully aquatic. And together with fossils of later Sirenians elsewhere in the world, these new specimens document one of the most marked examples of morphological evolution in the vertebrate fossil record. This brings us to the base of Sirenia, where the nearest relative in terms of morphological characteristics is not a Sirenian, but a similar-looking semi-aquatic Proboiscidean. Add that bit of knowledge to the fact that genetically, the closest living relatives of Sirenians are elephants. We've recognized 2 distinctly different groups of extant, still living species of African elephants, the forest elephant and the larger bush elephant, which are closely related to each other and more distantly related to Asian elephants. I wouldn't be surprised if most people thought that there was just one species of elephant, but at least you should know that the African and Asian elephants are different species. Georges Cuvier, the father of paleontology, examined bones from African and Asian elephants and determined that they differ from each other more than the horse from the ass or the goat from the sheep. So it should come as no surprise that there was only ever one hybrid recorded between them, and it only lived for a few days. Then, if anyone knows about mammoths, they might only know about the woolly mammoth, and they might think that it too is just an elephant. And genetically, they were more similar to Asian elephants than African elephants, but it's still a distinct species. There were different species of mammoths too, not just the woolly one. The biggest one was the Columbian mammoth, and that one was tropical. Then there are the mastodons, which are visibly different from the rest. And there were multiple species of those, too. And you can tell that they're related to elephants, but they're definitely not elephants. And that's just the beginning. As you can see, there were other older and weirder things that are still obviously related to elephants, but that are not elephants and never were. This chart mentions Moiritherium because they're well known as the mother of all elephants. However, critics will point out that Moiritherium lived in the late Eocene and early Oligocene, while Pesosiren, the earliest of the walking manatees, lived 15 to 20 million years earlier. But Moiritherium is not at the base of Proboiscidea. We know of a few others now, like Numiditherium from 46 million years ago, and Dowieitherium from 55 million years ago. And now Proboiscidea is even older than Sirenia, and we can keep going. Phosphotherium dates to between 56 and 60 million years ago, and Eritherium also hails from about 60 million years ago. Remember that the genetic divergence between these groups was indicated to be 64 million years ago. Now, as you'd expect, Eritherium bore traits that were consistent with what we would expect of the crown or the base of the line leading to elephants, while it also had features that were generalized and intermediate between that and the base of the other Tethythere lineages, so that the root of all three of these clades looked a lot like each other, and then they grew apart from here. As you can see, evolution being the one and only theory of biodiversity, most lineages are not linear, but are usually a side branch from something else. We see Sirenians going this way, Hyracoids going that way, Embrythopoda, and, these guys. Since we're looking at this chart, I have to mention these, Desmostylians. I didn't want to mention them, not in this video, because I don't think they belong here. But some charts include them, like this one does. And manatees are often called sea cows, but Desmostylians look a lot more like cows in the sea. They had short tails like cows, and they swam with these massive hooved paddles that probably would have been awkward on land. There were several species in their own distinct order, but where that order is rooted is unresolved. There was one study that noted similarities between these and Afrotherians, and another more recent one that suggested that they were closer to perissodactyls. So the issue is literally whether they're more like a hyrax than Hyracotherium. Desmostylians are the only order of marine mammals that are now entirely extinct, so we don't have their DNA to confirm their placement. The evidence we do have either way is about equal, except for the fact that all the Desmostylian fossils have been found around the northern half of the Pacific Rim, from Japan and eastern Russia to Alaska, California, and Mexico. So all the way on the opposite side of the world from where they should be, where they would be if they were Afrotheres. What I read said that there were as many traits linking Desmostylians to Laurasiatherians, and specifically Anthercabunidae, which is a family of stem perissodactyls that were semi-aquatic and that had also been once confused with Afrotherians many years ago. Plus, they're in Asia, and most Desmostylian fossils were found in Japan. So I think it's pretty clear we found the correct match, and this chart is wrong. Desmos don't belong here. That means I can't attest to the accuracy of the rest of this illustration either. We know there's a relationship between all of these, but without DNA for the extinct forms, we can't be certain that every one of these is in the right place. And while this chart says that it's about the evolution of Paeongellata, it's obviously really focused on Proboiscideans, which essentially means hoofed African mammals with funky noses. And they may all look like elephants at first glance, but they're not. And let's take a look at some of these, starting with Moiritherium. Look at the tusks. Elephants started out as relatively small hippo-like things until their teeth went crazy and started growing out of control. This is true of the whole order. That's the nature of inherited traits. And consequently, Proboiscideans are all recognized and categorized not just by their prehensile noses, which not all of them had, but by their outrageous dentistry. Barytherium was already pretty big, bigger than a cow at least, and we can't be sure whether it had a trunk yet, but it probably did have at least a short tapir-like nose, since Sirenians also have flexible faces. But the skull of the closely related Pyrotherium reveals that the incisors on both the top and bottom jaw had grown into short tusks, similar to what a hippo has. By this point, we can see that they already had what were probably very short tapir-like noses, but which were helpful for feeding. And for chewing, they relied on their molars, so they weren't dependent on the condition of their incisors, and it didn't matter that they grew so strangely that eventually they could use them as raking or stabbing weapons. That seems to be the case with Dinotherium, which was massive. and it only grew tusks on the bottom jaw. These are often depicted as having long trunks, but I suspect that they were shorter and fatter, matching their tusks, because they had to use their trunks to scrape food up on that bottom jaw. Same with Phoemia. This Oligocene semi-elephant is beginning to look the part, and it shows us how these teeth started growing a lot longer than they should have been. It apparently had a short trunk and 4 tusks, but the ones on the bottom have turned into a sort of shovel for a different style of eating than any modern elephant. This is a recurrent theme. Fossils of Gomphotherium from about 20 million years ago were found in Africa, Europe, China, Japan, and North America. They and other proboscidean species had spread all over the world, everywhere but South America and Australia, which were all island continents at that time. Gomphotherium also represents an important point in proboscidean evolution, when both the upper and lower incisors grew to such proportions that they were unusable for eating, and of course the length of the nose had to increase right along with the ever-extending teeth and lower jaw. These led to Paleomastodon, Trilophodon, Tetralophodon, and Platybelodon. The next really important stage of elephant evolution is when the lower incisors became tusks. Now, some of these species didn't have such shovel-like teeth anymore, and there was space left when the newly lengthened nose could now slide between the teeth, so that it could now be considered a true trunk, as seen here on Stegotetrabelodon. This looks familiar, doesn't it? Where have I seen this before? Oh yeah, these things. Obviously, there was a point at which these absurdly mutated teeth had become so long that they were useless for feeding. And worse than that, if they didn't have a trunk, they wouldn't be able to feed at all, because these flagpoles sticking out of their faces got in the way of everything, forcing them to use their already long and flexible noses to rake and trowel food into their mouths the same way that modern elephants still do today. Initially, both the top and bottom incisors grew out, as well as the lower jaw, but then a couple million years ago, every species that bore 4 tusks and elongated lower jaws eventually died off, leaving only Dinotheres and the more familiar-looking twin-tusked proboscideans like the Stegodont, which led to mammoths and mastodons and other species of proboscidean pachyderms not listed here. Then they all died off just in the last 10,000 years or so, such that the African and Asian elephants are the only ones we have left. One final point, though. Elephants are big. That's kind of their thing. They're the biggest land mammals alive today. A bull African bush elephant might stand 13 feet high at the shoulder and weigh over 10 tons. They might even be the largest land animals ever. Currently, the largest confirmed mammal is a Paraceratherium, a hornless rhino from the Oligocene that was over 15 feet high at the shoulder and weighed from 15 to 20 metric tons. It was so big that a full-grown man could stand tall beneath it and have to reach up to touch its belly. However, a few 100,000 years ago, there was an equally enormous elephant. Paleoloxodon pneumaticus was closely related to modern African elephants, but was even bigger, and maybe just barely bigger than Paraceratherium. According to Guinness Book of World Records, the estimates are based on a fragmentary skeleton and therefore are speculative, but the skeleton was that of a young male, not a mature bull. So if it had grown a little older, then it would have eclipsed the lower estimates for Paraceratherium, such that, yeah, it might have held the world record. Thank you for sitting through this with me. These phylogeny videos are my favorite ones to make, but they take a lot more time to compose and edit and find all the visuals. And yet I noticed that science documentaries don't get the views that, drama does. So YouTube doesn't pay for these. Patrons do. So thank you to all my patrons who have said that this is the kind of content that they want. And if you like these too, if you like whatever else I do, please see my Patreon page linked below or donate to my PayPal. I need all the help I can get. Go lay down. No. Go lay down. No. No. I am trying to record. Okay. You're hooked in my chain. Get there you go. Okay, go lay down. I'm trying to work. You guys make it impossible. Oop. Okay. All right. Go lay down.